Hi everyone. In the previous session, we have seen the sinusoidal response of RC circuit with AC excitation. So in today's session, we'll see the problem on that topic. That is, the problem statement comes like in the circuit shown in figure, determine the complete solution for the current when the switch SC is closed at t is equal 0. Applied voltage is V of t is equal to 50 cos 10 square t plus pi by 4. Resistance and capacitance are 10 ohms and 1 microfarad, 10 ohms and 1 microfarad, and we need to find out this current response. Like we discussed in all the transient cases, as a first step, what we have to do as a first step, apply KVL to the given loop at t is equal to 0. At t is equal to 0, if you apply KVL, R into I, that is 10 into I plus 1 by C integral I into dt, voltage across capacitance 1 by 1 microfarad integral I into dt is equal to supply voltage is minus plus minus plus minus. If you apply KVL, supply voltage is equal to drops across the individual elements. As a second step, you differentiate on both sides to get the differential equation. As you have one integral term, you can differentiate on both sides to get the differential equation. So 10I will become 10 into di by dt. Differentiation of integral will become only I by c is equal to, on the right side, differentiation of cos will become sine. Differentiation of 10t will 100t will become 100 will come out of that sine term. So remaining differentiation of cosine will become minus sine. That's why this is minus 50 into 100 into sine 100t plus pi by 4 as it is. Then I'll rewrite this equation as di by dt. I'll divide on both sides with 10, so that di by dt I by 10 power minus 5. So this will become minus 500 sine 100t plus pi by 4. So I can compare this, like I can rewrite this by considering this d by dt as d plus 1 by 10 power minus 5 of I is equal to minus 500 sine 100t plus pi by 4. So we have seen the derivation in the previous class. If you see the derivation, the complementary function IC is equal to C into e power minus t by RC. So R is equal to 10, C is equal to 1 microfarad. That's why you got 10 into 10 power minus 6, which is equal to 10 power minus 6. We got the complementary function, but we are having one arbitrary constant in that complementary function. To know this arbitrary constant, we used to use the initial condition that we'll see later. So what about the particular function? By assuming the particular integral IP as a cos omega t plus theta plus b sin omega t plus theta, we'll get the particular integral as a, in the derivation we have seen, v by under root of r square plus 1 by omega c square cos omega t plus theta plus tan inverse of 1 by omega c into r. By substituting the known values, that is, we know omega, which is equal to 100 from the given problem statement figure, and Vm is equal to 50, R is equal to 10, C is equal to 1 microfarad. That's what I have written here. So by substituting all these values in the above IP equation, we can get the equation like this. By solving this, or by simplifying that, we'll get the equation like IP is equal to 4.99 into 10 power minus 3 cos 100t plus pi by 4 plus theta is equal to 89.94 degrees. So now we got the current equation I as I is equal to IC plus IP, because already we know the IC equation. IC is equal to C into e power minus t by 10 power minus 5, and IP is equal to this equation. So by adding those two, we'll get the I equation. But in that IC equation, we have one arbitrary constant C. To know that, we need to use the initial conditions. So what are the initial conditions means? If you see this circuit diagram, at t is equal to 0 minus, earlier the switch was in open position. At t is equal to 0 minus, the switch is in open position. When it is in open position, the current flowing through this loop is 0. When current is 0, what is the voltage across capacitance? voltage across capacitance is equal 1 by C integral I into dt, right? When I is equal 0, voltage will become 0. That's why at t is equal 0 minus, switch is open, I is equal 0, Vc is equal 0. At t is equal 0, the switch is closed as per the problem statement. When switch is closed, the circuit becomes like 0. It is short circuit. And what about the capacitance voltage? What is the capacitance property during the transient? It will not allow the sudden change in voltage. So the same voltage, 0 voltage, will be maintained at t is equal 0 and 0 plus. That's why it will get short circuit. When it gets short circuit, what is the current? Current I is equal V by R. V cos omega t plus theta by R. But t is equal 0. That's why you'll get it as V by R into cos. This omega t is equal 0. That's why V by R into cos theta. Even at t is equal to 0 plus also, Vc is equal to 0. That's why you'll get the current as V by R cos theta. By substituting that, I of 0 is equal to V by R cos theta. Will get it. V 50 10 cos theta is equal to pi by 4 from the given problem. Theta is equal to pi by 4. That I'll substitute, so that I'll get the I of 0 value. I of 0 is equal to 3.53 amperes. So total I is equal to C into e power minus what we have done like earlier, IC and IP. By adding those two, I'll get the I. By substituting t is equal to 0, left side will become I of 0, and the right side C into e power minus 0, and wherever you are having t, here you have omega t, 100 into t, there also I will substitute t is equal to 0, so that your equation becomes C into e power 0 is equal to 1, on the left side I of 0 is equal to, already we have calculated, 3.53, and 4.99 into 10 power minus 3 cos, this term will become 0, pi by 4 plus 89.94. So out of this you'll get the C as, by taking this on the other side, you'll get the C value. Substitute that C value in this I equation, so it here C value, so that you'll get the same C value have substituted here into e power minus t by 10 power minus 5 plus IP, that which is equal 4.99 into 10 power minus 3 cos 100t plus pi by 4 plus 89.94. This is your solution. So in this way we can find out the current response in AC circuits. Thank you.